Hello everyone, I sit here in Istanbul together with Vadim Epstein, and we are happy to see you online and invite you to our artist talk of Vadim. I give the microphone and have fun.
Thank you so much for the introduction and to bringing me here to your audience, to the stream. So today I will show a few tricks about my recent works with animation in Stable Diffusion, because I was asked a few times already how to make that or that things. And also we'll give a brief introduction about our coming course, next edition of my course, AI ML in Visuals, which starts at the 1st of April. At the end of our stream, we will give some instruction. We will send some PDF file with few things, with some instructions from the course materials, which would help you to try it at home, to start it, not waiting till the course itself, and to try the things which I will show today, to install the stack for neural networks which I use, and to test animation methods which we will discuss today. So the main piece, which would be kind of like visiting card, is called Turbulence. It's to date one of most polished my work with video in Stable Diffusion. At the beginning of the year, I wanted to create something beautiful, not as usually like some creepy stuff which I usually prefer. And also during making of this video, I had to discover and apply, sometimes implement a few things which would allow me to make some such a high-resolution HD videos with good quality, with high frame rate. Here it goes like 50 FPS, 50 frames per second. This is the piece which I tried to make as abstract visuals. But under the hood, beneath of the result, there are a lot of things which are applicable and useful, I hope, for more realistic or for various kinds of animations. So let's see how the AnimateDiff, that is the main technique which is in use nowadays, the main open source technique for videos until Sora is widely available for public, but I doubt the OpenAI would release it as open source anyway. So let's talk about AnimateDiff for now. First, this great technique appeared as a way to produce very short chunks of video, like limited to the range of 16 frames. But the guys from ComfyUI community very quickly, very promptly applied some nice sliding window sampling technique, when we just take whatever amount of frames you want to generate, and we just shift our that limited limited range of frames, like those 16 frames, all over the whole sequence which we want to generate, with overlapping of different ranges, so that we have more or less smooth generation all over the sequence. And that was the time to start making some like music videos like this one, or some like lengthy animations. But at the time, didn't allow yet to make transitions between, for instance, prompts. So, like as this music video for Собаки Табака song, one of the leading industrial groups in my home country. Here I had to generate separate loops, separate chunks, separate pieces, every piece with one single specific prompt or set of prompts, because I used both textual inputs and imagery as image references with IP adapter technique, which greatly helps to achieve a specific style or specific look, specific feel for the result. And so here you may see that these pieces are edited just as cuts. We don't have any kind of transferring, any kind of interpolation between the topics. So here is this piece is in fact kind of what that turbulence nice abstract video would look as if I didn't apply that much of the reference imagery to allow the textual, the conceptual part to be surfaced. So in fact, the whole idea, the whole like art concept of turbulence video was to showcase our world, our like active life as some abstract process where we got a lot of events, a lot of dynamics, a lot of forces driving everyday life, but we don't see immediately or directly those forces, but can only see them through some turbulent waves of sometimes unrelated events. So here I just eliminated, I just decreased the weight of those abstract image references. Let me show you which kind of references I mean. These were few images which I which I applied as those image references, so that it would add that glassy, wavy look, making the whole thing abstract. But if I removed these references altogether, I would get pretty like noisy movements and not so consistent, not so coherent visuals in general. So if when I put a lot of like serious weights like 0.4 or 0.5 weight for IP adapter image references, and also add some extra words about these specific abstract visuals in the prompt, in the textual prompts, I would get that nice abstract image going smoothly from one prompt to another prompt, but we would totally lose the original imagery. And if I removed the extra textual guidelines to make it more like abstract glass works or whatever, but keeping the image references with low weights like 0.1 or 0.2, I got a pretty impressive result. That means that those image references didn't get into the visuals itself. You see that the imagery looks kind of realistic. Well, not that photorealistic, of course, but still we don't see any abstractions here. We see some hardly messed, but still recognizable pieces of some real stuff, people, nature, whatever. But keeping those image references intact, I really managed to make the whole movement way more smoother comparing to what it would be if I didn't add those references. So here again is what would exactly the same scenario like this. This is with really low weights with IP adapter references, and this is just with higher weights. So when you when you construct some prompts with images or text prompts, just consider the idea that when you do it with video, that you can juggle somehow, you can balance the inputs in such a way that you got one things going as visuals and other things affecting the motion, affecting the dynamics, but not getting into the visuals. That was a really good discovery for myself and really useful. Some other things which those of you who tried already, for instance, ConfUI, or by chance tried my GitHub repo, but in this case you would probably know already what I am talking about. Was that the main point of the main really cool, not even option, but feature of AnimateDiff, comparing, for instance, with early models, with early approach like ZeroScope or some other models. Those early models try to train a model at once for imagery, for visuals, and for movements. And they were, in fact, limiting both, because the model couldn't really learn the things in details. But with AnimateDiff, they separated these things so that you could take any Stable Diffusion model, originally any Stable Diffusion 1.5 models, family of models, and now the same is coming for SDXL, but didn't come yet for instance, to the popular diffusers library, which I use underneath my own code. And so you could take any existing model and apply so-called motion adapter to it, so that you animate the imagery of that model according to the getting both detailed visuals and much better, much more detailed animation. So, for instance, here's a brief example. This is some teaser of one of my earlier works, the poem, which we did a year ago with Ivan Pavlov, great musician. And here I fine-tuned a model, SD 1.5, onto some specific visuals, to specific style, imitating some ancient antique manuscript. So these visuals, this video on screen now was made with just interpolation with latent blending technique, which allowed really smooth, really stable transitions from one image to another, but it didn't really animate those visuals. It was just some kind of translation, some interpolation, some kind of animated slideshow. And in this case, using the AnimateDiff technique, I could just take that model, apply motion adapter to it, and getting the animated version of the similar, not really the same, but quite similar visuals from that fine-tuned model. So it's not all the time when you use some more complex model or more complex setup, you get a somewhat simpler result comparing to the like more simple task. For instance, if you want to generate just one plain image, that you can achieve way better, way more detailed and explicate results than you could achieve with animation. But still, using these separate models, one for image visuals, one for animation, really showcased that we still keep in a degree the style which we fine-tune in the original model. So let me show you a few examples of some other tricks which were used to make the turbulence video, both the abstract part and the realistic part under the hood. I showed already the image references which I used. So this was kind of easy extraction from the whole scenario. Scenario for turbulence included some like 30-something prompts. Here I just took 4 of them, the most like simple and understandable ones, and use them with the commands which I will show you briefly now on screen. But you will have the same. You will have all these instructions in the PDF file, which we will send at the end of the stream, so that you could try it yourself with your imagery, with your reference, with your prompts. So let's start with the first simple example. Here is just one line, one prompt, which I used also on my GitHub repo as a prompt example. That is fiery dragon in China shop. So this is generated with quite standard standard options without any extra specific tricks. And you see the result is recognizable. It's quite detailed, but we wouldn't call it any kind of quality one, because we've got this weird and noisy background. We've got very also noisy movements, like not smooth, not really following one piece of animation didn't follow previous. So. But that's just to let you see how the clear the original AnimateDiff technique would look now on its own. Next example already used those 4 lines text file which I showed, where we go through the through a few prompts, through a few requests. So we see both how AnimateDiff allows us to interpolate between meanings between tasks. Yet we see that despite the result sometimes maybe realistic or impressive, it's really clunky. It's the motion is quite sharp, and sometimes we get into some just noise. That was the second command where I replaced that prompt of fiery dragon with a text file which I showed you, so that we generate the whole scenario in one go. By the way, you see that here in instructions also another command, which is just handy handy command to automatically create a video file from your sequence of frames because generating with AnimateDiff or generating any sequence from the Python, you would usually get the sequence of, for instance, JPEGs or PNG, and the FFmpeg allows to easily, quickly, and with good quality to make it video. So next one. Next step was to add those abstract 3D image references to see how it would it help to make everything smoother and more coherent. So here you see that we may in fact find some kind of some traces of those 3D abstractions which were used as image references, but they are not as obvious. And if I didn't show you those references which I used, you would most probably would not notice that. But the smoothness of flow, the smoothness of dynamics is already enhanced. Yet we still have it quite fast, quite aggressive, and we would usually like to make it more smooth, to make it maybe slower, but not that really fast-paced. So next command, in fact, includes quite a few tricks. Besides using these image references with some low weights, we would also get here, we would also apply here two things. First, we would apply another motion adapter model, not the one which used the authors of that technique, AnimateDiff, but some other guys from which likely published it on Hugging Face Hub. That model had twice longer frame span, 32 frames instead of 16. And also I applied here one more technique, SAG, which stands for self-attention guidance. That's in fact a pretty old technique for, I don't know, a year or a year and a half, which in fact allowed more also coherent, more united composition for the imagery. Let me show you a few examples of what that those self-attention guidance applications. So here are few pairs of the image renderers made with different samplers, and for every sampler I made an image without that self-attention guidance and with. And while for some samplers it didn't really change much, there are some really tiny differences. But for instance, with SDXL, it was much more clear, much more obvious. This is for the most modern SDXL technique, SDXL Lightning, which use a distilled model allowing very fast rendering, very fast generation just for 2 or 4 steps instead of 50. And this one, here is an example with a standard SDXL model, which used longer generation for 50 steps. So the difference is pretty vast. But for using for SD 1.5 family of models, which I'm still a big fan of, I found that there is a sampler DDPM, which in fact is pretty obviously in an impressive way, is enhanced with this self-attention guidance. Like this is without, this is with guidance with low weight, and this is with guidance with higher weight. One thing for the DPM sampler to know yet is that it's not determined sampler. That means that even if you supply the same seed for generation, you would get a different result. So it's to be honest, that is not a really like scientific grade experiment, because next time if I render the same prompts, the same presets, I would with the same seeds, I would get different results. But on my experiments, I never got that detailed, that like impressive, realistic imagery without the self-attention guidance. I was usually getting more like these, and vice versa. Okay, so applying self-attention guidance helped a lot to get these vastly more elaborated imagery. So here's what I got when I applied both imagery references and these self-attention guidance with a longer span model to the same set of prompts. So you see that the result is quite controversial. While sometimes we kind of lose the point, we get some funny texture, not really getting the cool, detailed, realistic stuff. But sometimes, for some prompts, we do get those realism, those detailedness, and those really impressive quality. But that is already up to you, next to you. I showed at the beginning the example that it's possible to stay within the realistic realm if you want to be realistic. You just need to do your own homework for selecting and expanding textual prompts, and maybe some adding some extra image references, because I don't know about Confi.ui. I guess they'll also have it, but with my repository there is an option to use both to schedule, to use scenarios for both textual prompts and for image references. You just load, you just prepare the image, the directory with subdirectories, and each subdirectory have few images. And when you run the generation, it picks up one by one textual prompt and corresponding subdirectory with image references. So you can drive the result both ways. You got much more like both flexible and powerful ways to control it. And at the end, here the result of the same prompt of Fiery Dragon in a China shop, rendering again with generated with the tricks which I mentioned, with image references IP adapter, with longer model, and with self-attention guidance and DDPM sampler. So you can choose what kind of ways, what kind of styles, what kind of approaches you like more. I personally found that working with that smooth and stable animations is way more productive and way more satisfying than with these raw generation which we had at the beginning. So that's all about specific common specific tricks for AnimateDiff, for animation in Stable Diffusion. Again, if you're interested, you would get a PDF with instructions at the end of this stream. Now let me... Oh, sorry. Yeah, okay. So now let me briefly introduce to those of you who didn't really know by chance about our course AI Mail and Visuals. What is it about? That's the course for like in short by artists for artists. That means that I tried it to avoid two things. First, academic complexity, and at once being too specific, providing only like tutorials or bunch of instructions for some specific tricks or some specific methods, like I did now. Because the course it goes for 7 weeks, in fact 8 weeks, but we've got 1 week in the middle, spare one, so that you can keep up with the speed of the flow of the materials. And the last week of the course is dedicated for your own project, with which I would be happy to help you with. So 7 weeks of training, and it did our best to cover, in fact, the main things which I suppose are really useful to know, maybe not just know it as to have it always by hand, but the things, the theory which is really useful to for understanding what happens in fact in the neural networks, so that they won't be like black boxes for you anymore, if they are now. And also, of course, some practical instruments, some practical tools, so that you can start doing something right away from and after this course. So the first week, for instance, it's just like slow, relatively slow, of course, slow introduction into what neural network is, what instruments, what setup, what environment we will use to go through it. General brief introduction. Then convolutional networks, which are still in use nowadays, while they are more and more gradually replaced by some newer architectures like diffusions, transformers, etc. But still, first, convolutional networks are still important and still used for some tasks. And second, there are pretty a lot of really important concepts and the really important principles of what and how used in the neural networks, use constructions, buildings. So I guess this section will still be with us for quite a long time. Then the kings of the past, generative adversarial networks, which are still useful these days, even if you're total fan of Stable Diffusion or whatever, I don't know, Midjourney or any other modern foundation generative models, multimodal models. GANs are still can be applied for instance, to the results of your experiments with those multimodal generations. For some tasks, the GANs are still kings. Okay, then practical image processing is in fact, well, it can be divided for two parts. One is kind of excursion, observation over what kind of practical methods or artistic methods exist now besides the modern foundational models, or sometimes touching them as well. What methods do exist for image processing? starting from so as simple as upscaling or super resolution things, and going through kinds of deep faking and going to some really artistic and specific methods. So first 4 weeks, in fact, it was kind of the volume of the course which I taught 2 or 3, 4 years ago, before foundation models like CLIP, like diffusion models came on stage. And the next 2 weeks, multimodal networks and of course Stable Diffusion are dedicated to these modern methods. First, takes into account like explains the methods, the early methods before Stable Diffusion, which were not as not precise or not productive or not controllable yet as the methods nowadays, but still for some things they still may be useful, at least for artistic things. I'm pretty sure they are. And also, it's very I believe it's very important, very useful to know some principles which we used back then, only 2 years ago, to build new tools, to build new instruments which helped us to achieve things which were not impossible before. And the last week, obviously, about Stable Diffusion. It's quite useless to tell what exactly would be on that week, because the things move fast, you know that, and I'm pretty sure that at least 20–30% of what is listed here now for this week, which is based on the previous weeks only, on the previous edition only 3 months ago. Quite a few things are already replaced, upgraded, or removed, because we already have some pretty different landscape around. And as I said, the last week is dedicated to the final project. Kind of graduate project, which would be your chance to do something with the knowledge which you collect during the course, having me and maybe other students around to help you with that project, to assist you with the ideas, with technique, etc. Okay, that's probably it about the course program, and I think Stas would add a few things about logistics.
Oops. I slowly move in. So, first I should add something about the course itself, because in the course we have also a bit of Touch Designer integration, because like our platform is somehow related to Touch Designer, and I would say we offer not only all this amazing information which listed or Vadim told before, but also some kind of very puristic integration into Touch Designer. So in comparison to what is now on the market and available from Dot Simulate and other guys who integrated, for my opinion, it's not really an integration, it's just a connection to other platform. So we made a proper puristic integration of Stable Diffusion inside of Touch Designer component, completely running from Touch Designer Python. So that is very specific. So we will also have some lesson in the 4th week regarding that topic, which can bring you some ideas how you can use other complex Python tools running inside of Touch Designer. So for logistic, basically the course starts on, as I said before, on the 1st of April, and will be run on Monday and Thursday on GMT time +3, so which corresponds to 6 on Berlin time, or 8 on Istanbul, Moscow time. Then all lessons will be uploaded to the LMS, to Learning Management System, on our website, so all students have access to their backend and can relook to these lessons, download the projects and additional materials. and everyone has also everyone who signed for the course has an access to the student chat, which is, for my opinion, half of cost of the course, because it's like give the access to communicate with Vadim, with other students, with me in case you have questions to Touch Designer integration. And we also provide for everyone who is interested some PDF file with information you can download. So we will post the link now to the chat. So that's what I wanted to tell. Also, some last word for me, because I was also a student of Vadim in this course since, I don't know, since 1998. That's the first course I taken, and that old school methods Vadim explains, it's kind of bringing you slowly into cold water of new knowledge, because if you just jump into from the bridge into the river, it can be very complicated to survive. And slowly understanding all these old school methods, really seeing how neuron works and how you can teach the super simple network, which just learning on the simple digits, give you really smooth diving, and I would say academic diving in the concept, which is very complex. For me, I was really got several insights understanding how this evil machine works. So that was really amazing. And for us, like how to touch platform, to have an academic approach is very important. So like the border between academic approach and practical usage, what we try to achieve to make the compact education about complex things which are still practical but also academic, so bring the knowledge under the hood. So thank you, and I provide word back to Vadim.
Thank you, Stas. Yeah, in fact, I would only show you briefly a couple of videos relating to that mentioned integration with Touch Designer. Of course, I won't get under the hood for it. Welcome to the course for that. But here is first some maybe not really like informative videos. These are just my tests of the modern modern technique of SDXL Lightning. Like SDXL model was really impressive for quality, despite it had it was probably seriously censored and had a definite bias. But it was really produced in producing now still a really impressive results out of the box without any really tricky prompting, etc. And then there appeared such things as LCM models, which was approach to this so-called distill huge, heavy, slow diffusion models into way more fast, way more operative models, which allowed to generate stuff not within a few dozens of steps, like 50 steps of iterations through the diffusion steps, but only with as few as 2 or 4 steps. There was some LCM models for SD 1.5, but they didn't really. There were really few models which could be used, and training your own model, LCM model, is still a serious affair. You would need to get an access to the huge data set, etc. It's not like just homework on the laptop. So LCM was like thing in itself. It allowed quite like fast, quick things to do, and that was the method which we integrated Touch Designer with on the previous edition. But now, a few weeks ago, there appeared the so-called SDXL Lightning, which is as fast as the Excel Turbo or even faster, but has much better quality and again out of the box allowed to get pretty impressive results. So this is, for instance, some short video made, such short animation made with SDXL Lightning. It's not yet a proper animation with, for instance, AnimateDiff, which I showcased earlier on this stream. It's just an interpolation with latent blending technique, by the way, of the same short scenario which we tried as a test bed for AnimateDiff cases. But this was generated, for instance, with 25 steps, that is 25 frames interpolation between two lines. And then usually I was generating some steps, some intermediate frames with, for instance, Stable Diffusion. And then I had to, if I wanted it longer, to not wait, to avoid waiting too long time, I had to smooth it out, to interpolate it more with, for instance, film network, another neural model from the Google, to make this, to add intermediate frames between the diffusion generated frames, and so to make it smoother and like longer. And here I realized that with SDXL Lightning, you don't really need those extra smoothing networks anymore, because you can just generate more frames instead. Like here is the same task, the same scenario, but generated with 50 frames, twice more frames between the lines for as an interpolation step. And while we see that it's not, it didn't really get smoother in original, meaning that we still have some jumps between frames, which wouldn't go anywhere until while we use diffusion approach. But the macro shapes, the main composition, the main objects or subjects really move slower, smoother, and for describing or for showcasing the scenario from the conceptual point of view, we get better and closer to our task of presenting this scenario. And what I wanted to say that the length, the time of generating these extra steps between the, that is, generate them with Stable Diffusion in SDXL model instead of some extra smoothing model. The time was nearly the same. Well, in fact, it was longer, but not that much, not like tens of times as previously, but was something like I had 0.8 second per frame for diffusion, and I had something like 0.5 for the interpolation with extra model with film, just pure smoothing. So it became pretty much comparable. So, and obviously SDXL Lightning would be our model of choice for integration with Touch Designer on the next edition. And in fact, we already have something to show, probably showcasing the course better than all the words, or many words which we said today. That this video, it's maybe not really informative on its own, but this is the example of integration of of stream diffusion, which is in fact SDXL Turbo or SDXL Lightning, plus some other optimization tricks. So it's String Diffusion. I see it as a kind of like branding for umbrella term for few tricks. And as they say, Lightning on Turbo is the best trick amongst them. So here is an example of implementation of integration of String Diffusion with Touch Designer, but not done by us, not by me or Stas, but by our students from the previous edition of the course. Like we showcased them how to like properly integrate neural networks into Touch Designer. Showcased them on one of the examples was that we used Stable Diffusion LCM model, and Sumit Rahila managed to re-implement another model that is String Diffusion to Touch Designer without our help, with like quite simple. It's quite simple task. Okay, he didn't tell us how simple it was, or not maybe simple, but at least he did it on its own without any really like troubles or issues. And I suppose that's quite important to see that some the girls who just took the course only 2 months ago are already using it in their like day-to-day work, applying it to their installations or whatever. Okay, that's probably all I wanted to say.
It was a question regarding should the students know Python?
Good question. We tried hard. I tried hard to combine, to construct the program in such a way that it would be useful and interesting for both like cool specialists who are already may know Python, or may be experts in the coding in general. We had quite a few students on the previous edition who, in fact, did for as their grad project, made some database controlling my code so that they would use it integrated into their tool already. But at the same time, I tried hard to bring as much theory and as much general tricks and information in general for those who don't want to really become a coder, and who is not coder at all, so that they would be able to use already existing or other already existing tools, or the tools or instruments which are coming, so that they just know how it works, what it is, what its place and its role in the whole picture, so that this thing is probably should be used in such way and in such case, but shouldn't be used elsewhere. And to do something of different kind, you would pick up another instrument, so that they would see the whole picture and understand some necessary details. So, of course, the more you know, the more you get. That's obviously valid for, I think, any training, any education. But don't be afraid to get there if you haven't ever touched Python, or haven't ever just looked into the code. You may still get a cool insights, or at least useful info from it, even without coding any stuff on your own.
So I think it's a time to announce a PDF. So this link is available for everyone who was here in the stream, and you can download it just registering to our newsletters.
Thank you. for coming, and hope to see you on our course, or maybe on the coming edition, or later on, whatever, whenever you are ready to jump into that water, but not from the bridge, as Stas mentioned. And anyway, have a great success for your endeavors in other stuff for AML and for the rest. Thank you, and have a nice evening too.